Okay, let us discuss about the conservation of energy and momentum. Momentum includes linear momentum and angular momentum. Before discussing about this conservation of energy and momentum, let us discuss about work and energy. So what is a work? So if a force displaces an object, a work is done on the object. Or work done by an object is defined as the product of component of force in the direction of the displacement and magnitude of the displacement. Suppose a force is acting on an object. As a result of it, the object is displaces some distance. Suppose d is the distance displaced by the object. Then the work done is given by the component of the force in the direction of the displacement and the displacement. So work is simply written as the product of force and the displacement, or F is the force and D is the displacement. And the component of the force in the direction of the displacement is nothing but F cos theta. This component of force is F cos theta. If theta is the angle between the force and the displacement, then the work done is given by F cos theta into D. F cos theta is the component of the force in the direction of the displacement. So the product of these two, the component of the force in the direction of the displacement into displacement, will give you the work done. Otherwise we can written as W is equal to F dot D, because this is dot product is nothing but F D cos theta. So we can write work done as F dot D. When the work done will be positive, 0 or negative depends upon the value of this theta. If theta is acute, this will be a positive quantity. Work done will be positive. When theta is obtuse, the work done will be negative. When theta is 90 degree, work done will be 0. So the work done depends upon the angle theta. So let us discuss the case of a positive work done. So work done will be positive when the angle between F and D is acute, or F and D are in the same directions. For example, in the case of a freely falling body under gravity, suppose the direction of the gravity in the downward direction and the displacement, the body is freely falling one, so the direction of the displacement is also in the direction of the gravity. So the work done will be positive. The condition of work done is 0 when the displacement is 0. If the displacement is 0, there will be no work done. A person carrying a heavy load and standing stationary means there is no displacement, but there is force, but there is no displacement. But in that case also work done is 0. We know that W is equal to F dot D. If the force is 0, then also the work done is 0. Okay. This is a smooth ball moving in a frictionless horizontal surface. There is no force. We know that the body will continue its state of rest or uniform motion until it is acted upon by an external unbalanced force. If there is no force, the body will continue its state of rest or uniform motion. So when if there is no friction, the ball will move with uniform velocity. At that time also the force is 0, means the work done is 0. And the third condition is that the force and displacement are mutually perpendicular. A person walking along a straight road with a load on his head, in that case also the work done is 0. These are the three conditions for work done of a process to be 0. Let us discuss about a negative work done. Okay, when will be the work done negative? The work done will be negative when the angle between F and D are obtuse. If it is greater than 90 degree, the work done will be negative. For example, the frictional force. Okay, frictional force will act in the direction opposite to its displacement. So friction is a work done by the friction force will be negative. So these are the different cases of work done. Okay, let us discuss about the work done by a varying force. Suppose a varying force acting on an object from A to B. The force is varying because the direction of the force will be different at different points. So the force is a varying one. Okay, so as a result of this varying force, the direction of the displacement will be different at different points. So this is a varying force. Okay, so let us consider this point P and P dash. They are very close to each other, and as a result of this force, the particle is displaced from P to P dash, and the distance is too small. Let us take it as dr. So the small amount of work done to displace a particle from P to P dash is given by dw is equal to f dot dr. So the total work done to move a particle from A to B is given by integral A to B f dot dr. Suppose R1 and R2 are the position vectors of A and B, we can written as the work done as integral R1 to R2 f dot dr. So this is the general expression for a varying force. So W is given by R1 to R2 f dot dr. Dr is the small displacement happen in a very small interval of time dt. So W is equal to R1 to R2 f dot dr. This is the expression for work done by a varying force.